Hey, Applied Pre-Cal, welcome back. I hope the last lesson went okay. I apologize for the quality. Literally everything that can go wrong with like the editing process went wrong, so that was a pain. I think I got it figured out now, so hopefully this one will be a little bit better. We're gonna move on in our lessons to talking about the functions from our relations and functions. So we spent last lesson talking about relations and defining some of the words. We're gonna do the same thing here, except now we're talking about functions. So there's two words that I want you to understand. The first one is something called domain, and the second one is what we call the range. So the domain is the first set of elements in our relationship. So we made our lists and our arrow diagrams. We always had two lists, one on the left side, one on the right side. The left side is going to be our domain. The right side is our second set. That is going to be our range. Both of these words describe a set of values when we eventually get into graphing. So domain is all of our x values, that's on the bottom of a graph, and the range will always be your y value, so that's on the vertical part of the graph. Now, a function is a special type of relationship. Let's get the note down first, and I'll tell you a little bit about it. Okay, so a function is a special relation. That's where exactly one element of the domain is only going to associate with an element of the range. That's a bit of a mouthful, and it's kind of hard to visualize just with the definition. So we're going to work through an example here. Bear with me as I wipe the board, and then we'll take a look at what that looks like. All right, so we're back here, and I've actually started up an example here so that so you can see it. We're going to draw an arrow diagram. On the left side, my domain, I have the numbers 1 through 4, and on the right side, I have a bunch of vehicles. And I've already defined my arrow to represent the number of wheels on. So if we start with the number 1, 1 is the number of wheels on a unicycle. And we're going to complete this arrow diagram for the rest of our variables. 2 is interesting because it ends up having 2 arrows to 2 different things. And 3 and 4 each have 1 partner as well. So what I've drawn over here is actually an example of something that is not a function. And this is simply because our domain, one of our values from our domain, one of our elements, has more than one association with something from the range. This 2 has 2 arrows coming from it. That means it cannot be a function. So we need to rearrange our data a little bit here to hopefully make more sense of it. So just on the other side here, I'm going to cut ahead, but I'm going to draw the exact same set of data, but I'm going to flip it where my domain is going to be the vehicle and the number of wheels is going to be my range. So bear with me for a moment. Okay, so we're back. A couple of things that we have to do is first define what our arrow is going to mean. This part can be a little bit wonky if we're trying to force data to work. It might not sound great grammatically, but if it makes sense, we can use it. In this case, if our arrow says has the number of wheels, we can make it work, right? So I would never say a bike has the number of wheels too, but it makes sense. So we can work with that. So give me a minute. I'm gonna finish the arrow diagram here. You can follow along or work ahead if you'd like. But the key here is our domain. Every single element in our domain has exactly 1 arrow, 1 association coming off of it. It doesn't matter that both the bicycle and the motorcycle both associate with the 2, because the 2 is a part of the range. But since our domain has only 1 arrow coming off of it, that's going to be a function. So that's an example of a function. So I hope you have a moment to get this down. You don't want to pause and have that in your notes somewhere there. I'm going to wipe everything down. We're going to continue with the same example, but I want to show you something called a set of ordered pairs. We're back. All right, so set of ordered pairs is a way that we can represent the data that we have in a relationship, preferably a function. It starts by drawing one of these squiggly brackets. So if you ever wondered why a computer or your keyboard on your phone has squiggly brackets, it's for a set of ordered pairs. You start off, once you draw the first squiggly bracket, you're telling me that the set of ordered pairs is beginning. And sorry, that's the kid in me calling it a squiggly bracket. It's called a brace. If you're reading in your notes, you're reading your textbook, that's what they're referring to. So you open a set of ordered pairs with one of these braces, and then your first pair of elements that associate with each other, that have a relationship, go in the bracket. Your domain goes first, your range goes second. Okay, in this case, the unicycle associates with the number of 1. Unicycle has the number of wheels 1. We're going to continue on with that with every single one of our every single one of our elements. Okay, so typically you would do this in just one straight line. Sometimes you have so many data sets that it takes a couple of lines. If you're writing big, it does that as well. That's okay. Just make sure you're separating every single relationship with a comma. And once you've completed your set of ordered pairs, you need to close the brace. And that would be an example of a set of ordered pairs. What that allows us to do is we can immediately look at that data and figure out that our domain and our range are simply values that we can pull from our set of ordered pairs. Our domain is just going to be all of our x values. So I think I said x values, which is true, but we haven't learned that yet. The domain is all your independent variables, or all your values from the first list. So I've just listed unicycle all the way through to car. There is some order in the way that I've set them up. I've ranked them from least amount of wheels to most amount of wheels. I'm going to do the same thing with range. And you might pick up that I've only listed the 2 once for range, and that's simply because I don't want to be redundant. So you don't repeat the numbers again. It's just if you ever could have a repetition under your domain, you've got a problem. That means you do not have a function. If you have a repetition in your range, you don't have to write it. It just means that you're okay with that. Okay? And sorry, I bounced ahead there for a second. I said the word independent variable as well. Yes, I'm jumping ahead. Your domain, another word for that, is called the independent variable, or the IV, and I'll have a definition for that shortly. Your range is going to be referred to as your dependent variable. Simply, the independent variable can change. So I can change which vehicle I'm driving. Your dependent variable is going to depend on which vehicle that you're driving. And let's get that down as a note, and then I'll give you another example of what that looks like. Okay, so here's a set of the notes. You can write those down. I'll talk over just for a moment here, and then I'll give you a chance to get that down. So the independent variable, that is a variable that can change. So in our previous example, you can change the vehicle that you drive. You can't just change the number of wheels that you have. It depends on the vehicle that you're driving. And that goes into our range. You can't just change the number of wheels that you're driving with. It depends on the vehicle that you're in. And we're going to look at another example of what that's going to be as well. So if you don't have that down, you want to pause for a second because I'm going to erase it and move on to the last example that we have for today. Okay, so we're going to do one example here of understanding the independent-dependent variable, and then I'll tell you about function notation, and then that will cover everything that we need to learn for this lesson. Okay, we're going to do a table of hours worked versus gross pay. Sorry, this line was bugging me, so I did a quick cut. I'm just incapable of writing in a straight line, it appears. So we're going to we're going to make a table of the hours worked versus gross pay. So I just have a couple of random numbers here that come right out of your textbook. Okay, so you work 1 hour, 2 hours, 3 hours, 4 hours, doesn't really matter. Your pay, though, is going to depend on how many hours that you work. This is an example of your independent and dependent variable, and just another example, I suppose. You can change the number of hours that you work. If you work more hours, you're going to get paid more. Okay? You can't just change your pay. You can't just go to work one day and be like, yeah, I want to get $48 instead of $12 for working that 1 hour. It doesn't work like that. So we can change the number of hours we work. That's our independent variable. And our pay is going to depend on how many of those hours that we worked. Okay, so just another way of looking at it. Last thing I want to show you is something called function notation. So bear with me while I erase the board here and we'll go into function notation. Okay, I hope this isn't too overwhelming. I do expect it to be a little bit challenging because that is what this course is designed to help us work on. It's a lot of content here. We're building up into functions. Okay, so we started with just the definitions, elements, sets, understanding relationships. Today we're looking at a special type of relationship, which is what we call a function. We look at different ways that we can write that information, so either through a table, an arrow diagram, or a set of ordered pairs. And now I want to show you something called function notation. Okay, function notation is a way that your calculator would read a function or an equation, for example. So let's work through an example here and try to make sense of it. If your parents don't have a background in math, once you learn function notation, you can show them equations like this and freak them out because they look really complicated, but they're super easy to work with. First thing we're going to look at is the value of a quarter. Okay, so I'm choosing V to be my dependent variable, and I'm choosing Q, the number of Qs, to be my number of quarters. Okay, the V, the value, depends on the Q. That's what this notation is helping us understand. We don't need to have the definitions written down if we understand what we're working with, but just for the sake of your notes, we're going to write that down so you have that information. Okay, so V is for value, Q is for the number of quarters. So let's work through an example. Let's say, well, how much money do I have if I have 3 quarters? In your head, you could be like, oh, it's 75 cents. Yeah, I know you can do that in your head, but what's the math doing in your head? Or what's your calculator doing when you punch in 0.25 times 3? That's what the function notation comes into. So we're looking for the value, V, of 3 quarters, so V of 3. And because we changed our Q to a 3, we have to change the Q in our equation to a 3 as well. So the value of 3 quarters, that's what this first part is saying, is equal to 0.75. That is function notation. So I have some practice for you. I don't remember what page it was, so I will put that in on the post edit and everything. If you have questions about this, and I anticipate that you will, please feel free to email me. You can comment on the video if you like as well. And I'll get to you as soon as possible. Just finally starting to organize the videos, so I'll get there as soon as I can. Otherwise, good luck with your practice. For those of you that haven't had a chance to try the test yet, it is online and available. I haven't put a due date on it yet, but I'm thinking probably Friday at the end of the week. So please do get that done. If you have any issues with that, again, let me know, and we'll take it from there. All right?